Hello. Today we are going to talk about the Android build process. That is, what happens behind the screens when you hit that green play button and get your app running on the device. So here are some links to read further for those who are interested. First of all, of course, the Android Studio user guide and this particular page that talks about configuring your build, and through that gives us some information about how the build process itself works. The second bullet here is a blog on Medium, the Android developers blog. You will see many other interesting blogs in that series as well. But this one, the one linked here, talks about the different parameters of SDK version that are specified in the build process. So we'll come to that topic a little later, but that link is also informative. And of course, as I said, any related links from that page. So Android now uses the Gradle build system. Gradle is a flexible, efficient, automated build system, pretty much like some others that you might have heard of. For example, Maven and SBT. The last one is developed for Scala. It actually stands for Scala Build Tools, but is also applicable to other Java programs. Um, the more old school um, examples are, of course, things like Make, and then similarly Rake and such for other languages. But the ones listed here are more popular in the Java world. And when Android development was being shipped with Eclipse, there was use of Maven for building. Now it has moved wholesale to Gradle. Gradle is integrated in Android Studio, um, and we'll see the examples of how to write the files and so on. Um, but Gradle system itself is independent of Android and Android Studio. What that means is you can compile, build an Android project, and have the application servable on machines that do not have Android Studio installed. For example, continuous integration servers. So there you can just write a command line command and get it to build and then ship from there. So command line compilation is out of scope for our course, but interested people can look at the link that I mentioned before and see how it can be done from command line. Okay. So here is a brief overview of the build tools. These three are going to be the important stages or tools in that picture, and we'll see what are different inputs for these three tools. So first of all, the AAPT gets all your resource XML files and your Android manifest XML file, and produces what is called the R class. Now in the more recent versions, built into an r.jar directly. Earlier versions, you could find an intermediate step where it's converted to an r.java and then r.jar. So now the intermediate step is removed for efficiency. Next, after that, this jar file further goes into, oh yeah, by the way, AAPT also creates, compiled binary resources to be used in a later stage from the same input files. So it's just another way of looking at the resources from these input files. Okay. So then your source files, for example, main activity.java in the greetings project, along with any dependencies and libraries that may be specified, they all go to the compilers along with the r.jar, which the Java compilers, like Javac, they compile and combine together, and they produce the DEX files for you. So remember, Dalvik is the virtual machine for Android, and DEX basically stands for Dalvik executable. The next step after that is these text files and compiled resources, they go to the APK manager, along with any debug or release key store. So these keys are used for signing the app for debug purposes or release purposes. We'll talk a little more about this when we discuss publishing, um, which will come a little later. So all of these go to the APK manager. APK stands for um, Android package kit, sorry, and that is the one that produces your debug or release APK based on how you sign that one. So this is the overall build process. Um, we will be dealing, we will not be dealing with lots of details of this. Um, Definitely not for a long time, but it's a good idea to understand what is happening under the hood. So we are concerned with the abstracted level of these yellow boxes here, and we basically click that green button and get everything to compile and run for us. Okay, so now next we'll look into some of the files, what they specify and well, where they are specified. So if you're looking at the Android view of the project under Gradle scripts, you'll find all these .gradle and related files. So first of all, you have the settings.gradle over here, which basically, as the name suggests, defines the project level settings. And the code here in the right bottom corner is what our current settings.gradle file is. As you can see, it basically specifies which module to use in building and also the name of the root project, which in this case is greetings. And as you can see, app is the module um, for our app, and that is the one included in the project level build. Next, we have a top level build.gradle. Let me go back here. So yeah, there are two build.gradle files here. One is at the project level and the other at the module level. So each module can have its own build.gradle, and the top level or the project level build.gradle, as the name suggests, will deal with the project level configurations, and then you can have module specific configurations. Okay, so yeah, top level build.gradle will give us the configurations that apply to the entire project, and here is the file. This is what it looks like. So you have a build script block in which there are two sub blocks, repositories and dependencies. So these dependencies are the dependencies for Gradle itself. For example, the class path, you know, um, for Gradle, where the Gradle classes those files are. The repositories here tell you where to look for these dependencies. They can be local or remote repositories. In this case, we have two remote repositories, one from Google, the other from JCenter. And again, we don't really need to go into the details of these repositories. Most of it is a boilerplate code that we just use sort of out of box. Yeah, all projects specifies the repositories and dependencies applicable to all the modules in this project, as the name suggests. And once again, module-specific dependencies can be specified in module level build.gradle files. And finally, here we have a task. A task is a command to be invoked for specific instructions. Here, for example, clean is a command that, as you can imagine, basically deletes the root level build directory. Again, you might have seen similar tasks or commands in Make or other build tools that you have used. So in the Android Studio, you'll find a small green play button in the left margin next to the task itself. And if you have multiple tasks, there will be one for each. You click on that and just that task is executed. All right, so now we look at the module level build.gradle, which again, as the name suggests, configures a particular module like the app. And this file you can find if you go to the project view in the project tool window, you'll find it inside app. But the Android view gives it at the same top level, but then tags it with project level or module level, indicating whether it's one of these in the parentheses next to the file name. Okay. Um, yeah. So this is what that file looks like, and there is additional info which we'll see on following slides. So at the top, it says apply. It tells you which plugin to apply. So this is going to be an Android application. That's the plugin it applies. Then there is an Android block, which comes into the picture because of this plugin that is being applied, the Android plugin. And then you have this block. Inside that, you're specifying the compile SDK version, which is, yeah, which is basically the API level to use to compile this particular module. What this means is our app can use features of API 30 and lower. Build tools version, again, as the name indicates, is the version of the build tools used to build this app. And inside the default config blog, you have the application ID, no? And the minimum SDK version and target SDK version. So these are the interesting values, some of the interesting values here. So what we are saying is minimum SDK version is 19. Do you remember if we specified this anywhere? So some of you might have guessed, when you created the project, if you remember, there was a dialog box which asked you to specify the minimum SDK version. And we said it's a good idea to select one which has, a good number of devices out there, as the infographic shows through Android Studio. And we chose 19 at that point. So what this means is our app will not run on any device with API 18 or lower. This is the minimum SDK version required to install our app. And let me give a throwback to discussion on Android Manifest. It gets the values from here, and so yeah, what should be, you can think about what should be changed to get the app to run on other or more number of devices. And the answer is you'll have to change the SDK version and then compile the app again. Yeah. Yeah. So again, I refer to the second bullet in the second slide of this, where it talks about the relation between min SDK version, target SDK version, and compile SDK version. That may be that is likely to be likely important for when we go to publish the app and discuss what target devices or what share of market you are trying to target. Okay. One important thing to note is the compile SDK version cannot be lower than the target SDK version. All right, so for information on other SDK versions, this is the Android blog, which you can refer to. Okay. Other things in this file include the build types. So yeah, a little bit about build types. You can have a release or a debug build. So what it's saying here is minify enabled false for release. So you won't compress the code and make it a small or minified code even for the release version. You can set this parameter to true to minify it. And then if it is true, it will look for the rules to minify the code in this ProGuard file. So right now it's going to be empty. but here you can specify the rules using the ProGuard language syntax, and then those will be used to compress your code if you specify so. Okay. Again, something we won't be concerned with, at least not now, and rather, I mean, throughout this course, as a matter of fact. Yeah. Okay. The Android block can also specify different flavors or splits of an app. So flavors could be, free or a paid version where the app releases certain features in free and requires the users to pay to get to, more advanced versions. More advanced features of the app. Um, Similarly, there can be different variants of the same app based on screen densities and such requirements. All such things can also be specified under the Android block. Finally, you have the dependencies block inside this. And what you see under dependencies is the uh, the places or libraries which need to be included in the build. So most of these will be added by the IDE. For example, you can see you already have the constraint layout and the app compat on these two lines under here, which were, the lines were populated by the IDE. You didn't really have to do anything. You also see the JUnit and the espresso test libraries included here, and we'll see later how we can add more dependencies here based on the different features that we are going to use in our apps. Okay, so these are some of the main files. Apart from these, you have many other files, as we saw on that screenshot of the project tool window. I'll briefly mention some of these. The gradle.properties is a project level file. It specifies project-wide settings, like the maximum heap size and so on. Then you have an auto-generated local.properties. It's auto-generated, so you're not supposed to edit it or do anything about it, but that's where the environment properties, such as the SDK path, are extracted by the IDE and created for you. Then you have a gradle-wrapper.properties. This file defines the version and configuration for the Android Studio itself, version and configuration of Gradle. And again, Android Studio warns you in comments that you should not edit this file. It will update it with a new release of the IDE. Yeah, and finally, we have the ProGuard file, which includes rules to reduce the code size, as we saw on one of the previous, as we mentioned on one of the previous slides. Okay, so yeah, that's largely about the build process. And as I said, we will be working at a very abstract level. This video was more to give you a broad idea of what happens under the hood, which I think is an important discussion and something you should know about. And you should at least know where to look for if you are making any changes. Okay, all right. Next, we'll start talking about how the activity life cycles work. It will pause here. Thank you.